So what we've been looking at up to this point are values on the unit circle that are common. And what we're going to focus on now are uncommon values on the unit circle. And basically where we are is still on the unit circle with a radius of 1, but what we want to do is take a look at the ratios given that t is a real number and t would be equivalent to theta. It's just a different label, different variable, and the point xy. Okay, and we're saying that this is still a point on the unit circle, which means our radius is 1. It's just not going to look as obvious as it has in our previous problems. Okay, and we're going to take a look at what corresponds to t, and these are considered circular functions. So first of all, what you have to make sure you have and do, if you have not already, is memorize the following ratios. So when we take a look at our unit circle, here is our right triangle on our unit circle with a radius of 1. This is our x right here, and this right here is our y. And what t refers to is the arc length, okay, which is right here, okay? So this is what we're looking for. So if this is t, this is what we're looking for. All right, so one thing that we need to remember from geometry is our good old friend Sohcahtoa, okay? And this just basically helps us remember the relationship, okay, of the trig functions. So remember, sine is opposite over hypotenuse. So if this is the angle, opposite is going to be y over the hypotenuse. So this would be y over 1 or just y. Cosine is adjacent over hypotenuse, and this would be our adjacent leg over the hypotenuse, which is x over 1 or just x. And then remember, tangent is opposite over adjacent, okay, which is going to be y over x. These are all the corresponding reciprocal functions. So if this is y over 1, this would be 1 over y, 1 over x, and then when we flip this over, it's x over y. Okay, these ratios you need to remember, because now we're not always going to be referring to these as opposite over hypotenuse, adjacent over hypotenuse. When we're talking about sine, we're talking about the y coordinate. When we're talking about cosine, we're talking about the x coordinate. So here's an example of values that are not on, or they are on the unit circle, but they're not obvious. So here it says that t is a real number, and we're given some point xy. So this is our p, this is our point xy on the unit circle. So this is pretty key that you need to make sure you're reading the directions. This is a point on the unit circle that corresponds to t. So if it's on the unit circle, that means your radius is 1, and we want to find the exact trig values, the exact values of the 6 trig functions. When your directions say exact, what this means is that you will not be using a calculator. Okay, so one thing I want to point out here is that if this is our x coordinate and this is our y coordinate, and we're told that our point is on the unit circle, if I use the Pythagorean x squared plus y squared is equal to r squared, which we know our radius up here should be 1, if I take a look, I've got the quantity of negative square root of 39 over 8 squared plus 5 over 8 squared. This should be my r squared, which we want to be 1. When I square this, I end up with 39 over 64 plus 25 over 64, which is 64 over 64. This just proves to you that I'm still on the unit circle. Okay? All right, so what we're looking for here is the following. We have the sine of t, cosine of t, tangent of t. Since we know our radius is 1, if we're talking about the sine, if I go up here, remember it is your y coordinate, because this is on the unit circle, I would take 5/8 over 1, which is 5 over 8. So you notice this ratio is not a common ratio from the unit circle that we dealt with in the previous sections. Our cosine will be our x coordinate. Okay, so it's going to be negative square root of 39 over 8. And then our tangent will be our y over our x. So essentially what we have is 5 over 8 over negative square root of 39 over 8. And I hope you remember you have to simplify a complex fraction. So this is essentially 5/8 times the reciprocal of this, which would be 5 over negative square root of 39, which some of you need to practice rationalizing your fractions. So your final answer here would be negative 5 square root of 39 over 39. You cannot leave your answer unrationalized. Okay, so that's the first three. Now when we have to find the last three, we're basically going to flip these over. So this is going to be the cosecant of t, which is 8/5, because these two are reciprocals. When I flip this over for the secant of t, this would be 8 over negative square root of 39, and when we rationalize, it's negative 8 square root of 39 over 39. And then our cotangent of t is basically going to be the reciprocal of this. Don't go down here, go here. You're going to make your life a lot easier. Okay? Negative square root of 39 over 5. There's a negative there. And you're finished.